Next one, suppose should be given by Dr. Mahesh, right? Okay. So if you are ready, please go ahead for your presentation.
And first of all, good morning to my Indian colleagues and also hello to the Taiwan friends. And today, first of all, thanks to Professor Umesh Chandrasa for giving me this opportunity to deliver this bilateral India-Taiwan webinar on air pollution and public health. So my topic is on Earth observation systems for atmospheric application. And myself, Dr. Mahesh, working in National Remote Sensing Center of ISRO, Indian Space Research Organization, Hyderabad, India. So before I go into the topic, just I would like to give the research activity that we are carrying out at National Remote Sensing Center, ISRO. Like we are carrying out the dedicated observation network for atmospheric CO2, as we know that the importance of CO2. Over the Indian region, we have established a dedicated network, and this data is also made available to the researchers through our Bhuvan portal. There is a geospatial platform from the ISRO. We're also conducting polar research activities, airborne campaign for the atmospheric trace gases, which includes the pollution parameters as well as the greenhouse gases. And we have also studying the land, ocean, atmospheric interaction of these trace gases as well as the greenhouse gases. Also actively involved with the ISRO JAXA collaborative work and ISRO Indian Institute of Science, so that we are also working on the data assimilation. And I have seen the previous speaker, his work that I have seen using UAV, the measurements of O3 profiles. And we are carrying out ozone sonde balloon launching experiments over the Indian region at 4 locations simultaneously. And this slide, I'll skip that. You're all expert and you all know that why we are measuring the air pollution, how it is important, and how it is relevant to the public as well as the environment. So it has a adverse effect on both the environment and as well as the impact human health. And as part of our ground-based observation networks, we have established these flux towers. Like as you are aware, the atmospheric CO2 fluxes we are measuring from 4 locations as a function of the ecosystem. So 6 flux towers are established, and we have the dedicated observational network for the fluxes on agriculture. And apart from the agriculture, we have 6 unique the ecosystems covering from south to north. Even in the Jammu Kashmir, we are measuring the fluxes over the glacier side. And this is a ground-based FTR spectrometer, that is a Fourier transform infrared spectrometer, which is a kind of a hyperspectral, the ultra hyperspectral sensor, which gives a using the electromagnetic spectrum, which the FTR spectrometer measures the electromagnetic spectrum from the sun as the active source. And using the spectrum, we retrieve the atmospheric CO2, CH4, carbon monoxide, nitrous oxide, water vapor, ozone. So some of the major pollutants, even the hydrogen fluoride, hydrogen chloride, the gases that we are retrieving using the single spectra from Indian side. And this is the first of its kind in the country that we are measuring the simultaneous measurements of all these pollutants and greenhouse gases, especially the special emphasis on greenhouse gases using this ground-based FTR spectrometer. And any ground-based observations are decisive in validating the satellite observations, so that this data has become a benchmark for the validating the satellites. And as part of the CalVal activity, we have validated the Sentinel-5P tropomy, which gives the high-resolution pollution parameters like carbon monoxide, nitrous oxide, and formaldehyde. And here, using our FTR spectrometer, we have validated the carbon monoxide, column carbon monoxide from the tropomy, also the methane concentration. And if you see in the left side in the circle, the radial plots, they talk about the interaction between urban suburban interaction. The center of the circle is our suburban site where we are measuring from where we are measuring this FTR spectrum based spectrum, and the distance away from the center is the closest to the cities. So we can see the high concentration versus low concentration. The gradient is very much evident that the suburban and urban to suburban interaction of these pollutants in this region. So we have done this study for the carbon monoxide and methane, which got published in IEEE GRSL in 2022. And I have seen one of the speaker also talked about the airborne profiles, and we are also actively carrying out these airborne profiles. And previously we have only carried out the airborne profiles for the atmosphere CO2. Now we are planning to measure the atmospheric pollution, pollutant parameters, and also the greenhouse gases. So as part of our project, that is the main objective, to cover the pollution and as well as the greenhouse in terms of environment and climate. So the typical structure of the vertical profiles, if you see, they are in lower concentrations having in the surface, higher concentration in the surface, lower altitudes, whereas the lower concentration in the upper altitudes, because the surface characteristics are the major driving force or driving factors for the emissions of the CO2 in the atmosphere. That is why we can see that the higher concentration in the lower altitude and the lower concentrations in the higher altitude. And how does this information is useful? So when it comes to the radiative impact, so the long-term and seasonal based, the vertical profile information is very much useful to assess the regional climate induced by the individual greenhouse gases. We are already across the globe, the researchers are already doing using SB dot model, the warming effect of the due to the aerosols when we simulate it. So similarly, we wanted to use the radiative transfer model to estimate the radiative impact by these greenhouse gases and the secondary greenhouse gases, which comes primary pollutants in the atmosphere. So these are a typical structure over 3 locations of India that we carried out during 2016 period. And now we actively, this year we are going to start with a comprehensive manner to cover both the greenhouse gases as well as the pollution parameters. And this is a ozone sonde balloon launching experiment. At a time, we are launching from the 4 locations to study with a varied scientific applications, especially to understand the troposphere-stratosphere exchange. Also, to validate the Indian satellite, especially INSAT 3D, 3DR, our geostationary satellite, which gives the profiles of meteorological parameters: temperature, pressure, humidity, wind speed. So these parameters, besides the calibration and validation, there are a lot of information about the vertical information, using the vertical information to address the scientific problems such as the troposphere stratosphere intrusion. Also, during the convective processes and advection process, how this mass is getting exchanged between the stratosphere and troposphere. So these are the 4 locations which are latitudinally equally homogeneously distributed across the country. So we are actively launching these from our Indian sites. And this is one study that recently we have done using the nightlight data from the Suomi NPP, and also the air pollution parameters from the our Tropomet data. So that shows the nightlight data is acting as a proxy for the air pollution in the urban areas. So we can see that wherever the development is actively happened in with respect to 2019 and 2023, between 2019 and 23, the nightlight activity is also increased by 50%, and the pollution is also increased in commensurate with the nightlight data. So this recently we also communicated to a journal, and this shows the how nightlight data can be used as a proxy for the development and urbanization, also the environmental impact. And we also know that how the lightning is also affecting on the NO2, though it has a lesser contribution on NO2 production, which comes naturally due to the lightning activity. But when it comes to the radiative impact in the upper atmosphere, the quantity of NO2 induced by the lightning is also important. So we try to map that the probable hotspots, probable regions, and during the time period, which time period the lightning versus the NO2 has a strong correlation, and which resulted pre-monsoon, monsoon is having a strong correlation at different parts of the country. So that the color bar shows the correlation coefficient between lightning and NO2. And we know that in India, pre-monsoon and monsoon are the two seasons which have a strong the lightning activity. And post-monsoon, the post-monsoon basically it is both because we don't see much correlation, but the biomass burning effect is dominant during the post-monsoon season. But if you see with the lightning activity, the correlation is very poor. And the second level of sensors have come into the space-based sensors from the like GOSAT, which has a GOSAT-based, JAXA-based GOSAT sensor, which gives a regional picture of the emissions of CO2 and methane. But whereas the European Space Agency in the recent years, 2018, 2017 onwards, the Sentinel 5P tropome is giving very high resolution data at the rate of like 5 by 3.5 kilometers square. So using this data from regional level to the point level, we are able to see the emissions. In the bottom right, if you see the plot, the 3D graph, the 3D plot shows that the higher emission zones of India. So the emissions, which are the peak, the height of the peak depicts the emission, the quantity of emission. So Indo-Gangetic Plain zones are the hotspots for the methane emission, because these are the zones which has the dense population, as well as the dense industrial activity, also the kind of rice wheat based agriculture system in this. And this using further the technology, like we have moved to the hyperspectral imaging sensor. Using hyperspectral imaging sensor with our own ISRO's aircraft, as part of the ISRO NASA collaboration, we have flown the advanced visible infrared imaging spectrometer next generation payload on board ISRO's aircraft, and we could map the methane emissions using the radiance data. And similarly, in the recent years, the new development from the International Space Station, the emit sensor will also gives the radiance. So we are able to detect the methane. The bottom right figure shows that the methane emissions over the plumes. So basically, this picture urban region there where there was no active source, but we could see that the methane concentrations, dispersion of methane around 800 to 1000 ppb. But if it goes to the source location, it will be around 2000 ppb, 1950 ppb. So it demonstrates the potentiality of the remote sensing technology in detecting from regional level emissions to the point level emissions. And we moved also to the UAV platform. I've seen one interesting plot by the previous speaker, which he could measure the profiles up to 1 kilometer. Right now, we are in the prototype development, and we are able to launch. We could fly up to 100 meters, but we need to explore that kind of results, like 1000 meters, the altitude. So this is the quadcopter UAV we are using for measuring the pollution parameters as well as the meteorological information. So the like for a better air quality system or development of better air quality system, using the comprehensive the resources, the availability of resources. So we have today now across the globe the dense network of informations. Also the resolutions in terms of resolution and the coverage has increased a lot, and also the geostationary satellites also have increased for the air pollution measurement. So by integrating all this, we'll be able to give very decisive information for the public as well as the policy decision makers. And recently we have also developed a smart system for tracking the air pollution, so where we'll be able to see that the buffer of 25